When people hear the word comparability, they often get a very specific image in their minds. They think about numbers. They imagine two columns of data, side by side, and ask a simple question. Do the numbers match? Are the values the same? But here's the thing. That mindset completely misses the point. It's a fundamental misunderstanding of what comparability is all about. Comparability isn't a game of numerical matching. It's not about sameness. It's about meaning. And once you understand that distinction, everything changes. So many teams ask the wrong question when it comes to comparability. They look at two data sets, one before a change and one after, and they ask, do these look identical? That question sends you down a rabbit hole of statistical tests and decimal point chasing that often leads nowhere productive. The right question, the one that truly matters, is whether the data still mean the same thing. Do the results, even if they look a little different, support the exact same scientific conclusions about the product's quality and safety? That's the real goal. So, what is comparability, really? At its core, comparability is about preserving scientific meaning across change. In the world of drug development, things are constantly changing. Your manufacturing process changes. Your analytical methods change. Your raw material suppliers change. Even your formulation might change. The whole point of a comparability exercise is to demonstrate that despite these changes, your understanding of the product remains consistent. It's about ensuring continuity of knowledge and confidence, not about forcing numerical duplication. And let's be clear, change is not just common, it's inevitable. It's a fundamental part of the drug development lifecycle. Processes evolve from small-scale lab batches to large-scale manufacturing. Analytical methods get more precise and more powerful. Better suppliers are found. In fact, you could say that comparability exists because development exists. If nothing ever changed, if your process was set in stone from day one, you would never need to do a comparability study. So, embracing change is part of the job. This brings us to what I call the number matching trap. It's one of the most common mistakes I see. A team makes a process improvement, generates new data, and then panics when the new numbers don't perfectly align with the old ones. They get trapped in this mindset that the numbers must match exactly. This often leads to a cascade of bad decisions. Unnecessary rework to force the numbers to look the same, overinterpretation of tiny, insignificant differences, or worse, conclusions that are technically precise but scientifically misleading. But why do numbers change in the first place? It's usually for very good reasons. Let's say you upgrade an analytical method. The new method might have improved resolution, allowing you to see things you couldn't see before. It might have reduced background noise, making your signal cleaner. Or maybe it has better specificity, meaning it's less likely to be thrown off by other substances. These changes in the numbers don't automatically mean the product itself has changed. More often than not, they mean your ability to measure the product has gotten better. Now, you might be wondering, what do regulators think about this? Well, contrary to what some people fear, regulators are not looking for identical results. They are not expecting you to present two perfectly matched columns of data. What they are looking for is a scientifically sound argument. They want to see that you've thoughtfully considered the change and can demonstrate, with robust data, that the product remains comparable in terms of its quality, its safety, and its performance. It's about the story your data tells, not just the numbers themselves. A critical piece of telling that story is understanding your method lineage. Method lineage is the history of your analytical methods. You need to be able to trace how your methods have evolved over time. What specific improvements were made? Why were they made? And most importantly, how do those changes affect the data you're looking at today? Without that historical context, you're just staring at a spreadsheet of numbers, and it becomes incredibly easy to misinterpret what they mean. The history provides the context for the comparison. This is why the strongest teams I've worked with design their comparability studies with intention. They don't just react to a change and scramble to gather data. They plan for it. They proactively design bridging studies to connect the old and the new. They retain representative samples from old batches specifically for future comparisons. And they define what success looks like, their acceptance criteria, before they even generate a single data point. Comparability is always strongest when it is a planned, deliberate activity, not an improvised reaction. And here's another key point. The comparison needs to be fit for purpose. Comparability doesn't mean you have to do a full, side-by-side recharacterization for every tiny change you make. That would be a massive waste of time and resources. The depth of your comparison should always match the level of risk introduced by the change. A small, well-understood change might only require a few targeted tests. A major process overhaul, on the other hand, will demand a much more extensive data package. It's about making a smart, risk-based decision. So, when does comparability fail? It typically fails for one of two reasons. First, it fails when teams get stuck in that number matching trap and rely on raw numbers without any context or scientific story. They present the data and just hope the reviewer sees what they see. The second failure mode is when they can't explain the differences they observe. If numbers do shift, you must be able to explain why they shifted, why those differences are expected and acceptable, and how any potential new risks are being controlled. Ultimately, this comes down to leadership. Analytical leadership has a responsibility to frame comparability correctly within the organization. It's not a statistical coincidence you're hoping for. It's a scientific argument you're building. Leaders need to ensure that the story being told is coherent, defensible, and appropriate for the stage of the development program. They set the strategy and the philosophy that guides the team's work, moving them away from number matching and towards building a compelling scientific case. So if there's one core insight to take away from all this, it's that comparability is not about matching numbers. It's about preserving meaning through change. It's about being able to confidently say that even though our process or our method has been updated, our product today is just as safe and effective as it was yesterday. If that meaning is preserved, if that story holds true, then the program can move forward with confidence and speed. And the practical takeaway for you is this. If you find yourself in a comparability exercise where the numbers are UNT perfectly identical, don't panic. Instead, ask yourself if you can clearly explain why the differences exist. Can you explain why they matter, or, just as importantly, why they don't matter? And can you show how any risk is being controlled? If you can do that, then you are doing comparability correctly. You are building the scientific argument that matters most. In the next video, we're going to build on this and talk about the unique challenges of late-stage analytics. We'll explore what truly changes as programs approach Phase 3 and commercialization. And I'll highlight some of the key things that many teams underestimate until it's almost too late. It's a critical transition point, and you won't want to miss it. Thanks for watching, and I'll see you in the next one.